We are going to finish up our study of transformations by looking at reflections of the graphs. You guys will notice that when we did our multipliers before, we did multipliers that were greater than 1, and you'll remember that this makes a vertical stretch. It pulls the graph away from the origin. We looked at what happens when the multiplier is less than 1 but still positive. This is a vertical shrink. It smashes the graph toward the origin. And the question we're going to consider today is what happens when the multiplier is negative. And what we're going to learn is that when the multiplier is negative, this is a reflection. It flips the graph over the x-axis. There are also horizontal reflections. We are just not going to focus on those this year. We're only going to focus on vertical reflections. Okay, so let's look at this graph. Y equals negative x squared. So you can see that what I have graphed here is the parent graph, y equals x squared. That's my parabola. And this negative that's right here, that is going to be a reflection. So anytime I have a negative right here, it's going to flip. What number is understood to be right here? Okay, well, that's an understood 1. So I'm not going to dilate the graph. I'm not going to shrink it or stretch it. I'm just going to flip it over. So the points that are on the x-axis stay on the x-axis. That's what I'm flipping across. That's my line of reflection. So anything that's on the x-axis stays on the x-axis, which means right here, that point that is the vertex is going to remain the vertex. But what's going to happen is that my parabola is going to flip upside down. And so I'm going to end up with this. It's the same shape, or the best I can draw with my finger. It's the same shape. It's just now that it's upside down because it is a reflection. But I could have a -2 right there, right? There's no rule that says I'm only allowed -1. I could just as easily have a -2 there. And when you see that, you need to think about this 2 different ways. Put this on your paper. You need to think about the fact that the negative is going to be a flip, or that reflection, to use the appropriate mathematical term. That word is reflection. And then the 2. Okay, so the 2 is greater than 1. Ignoring the negative, just focusing on the 2, or looking at the absolute value of -2, if you want to think of it that way. 2 itself is greater than 1, so that is going to be a stretch. That's going to be a vertical stretch. So in this case, I'm going to do 2 things. I'm going to flip my graph over the x-axis, and I am also going to stretch it. So this point right here, 1 squared is 1, right? That's what it would be on the parent graph. But I'm going to take that 1 and I'm going to flip it down and make it -1, and also multiply it by 2 because I'm going to stretch it, and I'm going to end up at -2. So that point that was 1, 1 is now going to be 1, -2. And the same thing is going to happen on the other side of the graph. That point is going to be at -2 as well. So when I connect the dots, this graph, oh goodness, this graph is going to end up being much thinner than the graph above it. So 2 separate things going on here. I have a reflection, and at the same time, I also have a dilation, or I have a stretch. So there's my graph flipped upside down and also stretched. Okay, well, my number that's multiplied right there could also be in between 0 and 1. Again, I need to think of this as 2 separate things. My negative is going to be a flip or a reflection. And the 2/7, well, 2/7 is less than 1, so that is going to be a vertical shrink. It's going to take my graph and smash it closer to the origin. So I'm going to flip it upside down. And also, if I smash it closer to the origin, it's going to become fatter. So that's what's going to happen with my parabola. Now, y'all did parabolas in Algebra 2, so hopefully that's just a reminder of what the parabolas are going to look like. Okay, so here's one we didn't do in Algebra 2. Here we have -4 to the x. Okay, so we're going to not focus on the negative right now. We're going to focus on the 4. A in this case is going to be 4. So 4 is greater than 1. So does this make this a growth graph, or does this make this a decay graph? Well, it's going to be growth, right? When A is greater than 1, and in this case A is 4, which is greater than 1, this graph is going to be growth. Okay, so I have here the graph 4 to the x. And now let's look at what happens when I have that negative. Okay, what does the negative do? The negative is a reflection. So you can see right here, I graphed this with technology, so it appears that my graph is laying right on that axis right there, but we know better. We know that that is really an asymptote, and that the graph itself is slightly above the asymptote. So when I flip it over, the graph is now going to be slightly below the asymptote. And look, there's my anchor point. It switched from right there at the point 0, +1 down here to the point 0, -1 because it was a reflection. It flipped over the x-axis. Okay, but just like before, I could flip and also have a dilation. So I need to still think of this as two separate things. That negative is my flip or my reflection. And 2 is greater than 1. So is this going to be a stretch or a shrink? It's going to be a stretch because 2 is greater than 1. So I still have my asymptote right here. The fact that I'm stretching doesn't change my asymptote. What it does change, my anchor point that was right here at 0, 1, the reflection pushes it down here to 0, -1. It flips. But then I also have a stretch by a factor of 2. So it's going to end up being down here at -2. So my new anchor point is here at 0, -2. And then my graph is going to still go flipping this part over. It's still going to be going very steeply on this side. It's still going to be going not steeply on this side, but the anchor point has moved from 1 to -2 because I reflected it and I also stretched it. Okay, so here's another one. This time I have that negative, which we know is a flip or a reflection. I'm just going to abbreviate there. Now 3/5. Is 3/5 less than 1 or greater than 1? Well, it's less than 1, which tells me I'm going to have a shrink. I'm going to smash it closer to the axis. Again, that's not going to affect my asymptote. What that does mean is that my anchor point that would have been right here at +1, I'm going to do a reflection and put it at -1, but then I'm going to multiply by 3/5, so it's going to shrink up closer to the origin than it was before. Same shape, right? I still have very steep on this side. You can see that right here. I still have very shallow on this side, and you can see that right here. But my anchor point has moved from +1 to -3/5. Okay, let's look at what happens when I have a trig graph. Okay, so let's talk about amplitude. Do we remember amplitude? What does that measure? It measures the distance from the midline either to the highest or the lowest point. Here's the midline right here at y = 0. And the amplitude of just plain cosine, which is what I have graphed here, is 1. So cosine goes from 1 to -1. Okay, so what does this -3 do? All right, well, first of all, I don't want to think about it as -3. I want to think about it as a negative, which is going to be a flip or a reflection, and also a 3, which is greater than 1, so that's going to be a stretch. And you remember from the last video that when we stretch one of our trig graphs, what we're doing is we're changing the amplitude. So instead of going from 1 to -1, it's going to go from 3 to -3, or I probably should say -3 to 3 to say that in the correct order from smallest to largest. Okay, so I need to do two things. I need to reflect it, and I also need to stretch it. So this point that was right here at +1, I'm going to have to do two things. I'm going to have to reflect it down below the x-axis and then also stretch it. That's going to end up being down here on -3. My points that are on the axis stay on the axis. Just like with the algebraic graphs, the same thing is true with the trigonometric graphs. Those stay on the axis. And then I'm going to reflect, which means the hills and the valleys are going to flip-flop. They're going to go the opposite way, and they're also going to be taller. So I'll start here at -3, go through 0. I want to go all the way up to +3, back down to -3. All right, let's do the same thing here. -3 to +3, back down to -3. So my red graph that was drawn on there by Desmos, that is just regular cosine of theta. My blue graph that I just drew with my finger is -3 cosine theta. It is reflected because of the negative, and it is vertically stretched by a factor of 3. Okay, let's look at secant. You guys remember secant is the reciprocal of cosine. So I'm going to take my cosine graph and I'm going to make secant from that. So what I have here dotted in red is the cosine that I just did, -3 cosine theta. That's what's dotted right there in red. And you remember that secant has asymptotes wherever cosine hits the axis, right? Because secant is the reciprocal of cosine. So therefore, when cosine equals 0, secant is undefined. Everywhere the graph is undefined, we're going to put an asymptote. So I did those with technology. I thought it made the graph look a little bit confusing when I tried to do that with my finger. So there are our asymptotes done with technology. All right, and then if you remember what secant does is it basically just flips cosine over. So I'm going to take each of my bowls and I'm going to flip it over. So the -3 that's right here, I used that to change cosine. I drew in -3 cosine theta, and then I'm going to use my cosine graph that has already been transformed to do the secant graph, and it'll automatically be transformed to be the right thing. So if you look, I'm going to flip each one of my little bowls towards the asymptotes. All right, so if they were down, they're now going to be up. And if they were up, they are now going to be down. Okay, and you can see that I'm still approaching the asymptote both above and below the axis. But this time, because of the 3, I have a +3 right here where my little bowls start. And I have a -3 down here where my little bowls start, and there's nothing in between +3 and -3 because that's where cosine would have been. All right, let's do tangent. So I've got -1/3 tangent theta. So that negative is going to be a flip. That 1/3, is that going to be a shrink or a stretch? Well, 1/3 is less than 1, so that's going to be a shrink. That doesn't affect what happens on the axis. So I'm still going to have zeros in these same places. It also doesn't affect my asymptotes. So I'm going to go ahead and put my asymptotes in there so I have something to aim for. All right, that negative is going to flip all my little red tangents over, and that 1/3 is going to make them flatter. So if I do that, I'm going to flip over and become flatter. So you guys can see at the origin, see at the axis rather, that it's a little bit flatter than it would have been. Still not going past the asymptotes, up and down to the asymptotes on both sides, but a little bit flatter than it would have been. Okay, so the red that's in there, that's my parent graph of tangent theta. The blue dotted lines, those are my asymptotes. And the purple, that's the answer. The purple is -1/3 tangent theta. So my 0 values, my x-intercepts did not move, they did not change, and my asymptotes did not move or change either. All I did was change which direction the graph was going, and I smashed it down closer to the axis.